you to my presentation. My name is Hieu and I come from Faculty of Mechanical Engineering at Hồ Chí Minh, University of Technology and Education. The topic is motion control of a three-wheel the 3-articulated mobile robot and condition-free human flowing navigation in outdoor environment. The presenter is me. The instructor is Associate Professor, Doctor of Philosophy Ngoc. The authors are Yong-Siu E. Abdelgabbar, Ja Hong Lee, member IAENG, and Shingo Okamoto. Today is Sunday, May 15, 2022. Let's go to the content. In the content, I have 4 parts. First is the introduction. The second is the methodology. There are modification of the mobile robot system, motion control. The third part is the result. They are navigation using joystick commands and running speed, human flowing with static obstacle, human flowing with moving obstacle, and the finally part is the conclusion. Let's go to the first part, introduction. So nowadays the interest is growing in the potential of human sympathetic robots. So what is a sympathetic robot? You can see in the picture 1. It's a 3D one human sympathetic robots in Tokyo, Japan. The sympathetic robots is the robots can do the simple work like help people when they have lunch, have dinner, clean the house, talk with the young children and the needy people. So the author of this research have opinion to create the wireless mobile robot. It can following a running version, avoiding collision, and it can work in the outdoor environments. The methodology. The first is the mobile robot system. You can see we have 2 figures. The figure 1 is the mobile robot system. It has the 3-wheel. It has some sensors and some actuators. You can see the laptop, the camera, LRF is used to recognize the target person and people around the robot. The battery to supply the power. The developed steering wheel. You can see the detail in the figure 2. It has the servo motor, the gear, the caster wheel, steering assist. The servo motor is used to measure the steering angle of the front wheel, and you can see the embedded microcontroller is used to control the 2 rear wheels of the robot. We go to the configuration of the mobile robot system. There are 3 main parts. The part 1 is the sensor, part 2 is the laptop computer, and the part 3 is the mobile robot platform. You can see here the robot sensor has 2 parts. They are camera and the LRF. It sends the image data and the scan data to the main program in a laptop computer. After that, the laptop computer will process the data and send the data to the embedded controller by the SA boot. The embedded controller will control the motor. So we go to the kinematic model. We have two equations. The equation 1 is the linear velocity and the angular velocity of the robot. You can see the figure 4. This is the kinetic model of three-value robot. So what equation mean? It means if you have the radius of the left well and the radius of the right well, also you have omega left, omega right, and you have the distance between two well is t. You can calculating the velocity and the angular of the robot. The equation 2 is the differential equation. This is the equation for the steering velocity. So what it means? You can see the S phi c equals sin phi c. The c phi c equals cos phi c. And it means if you have the radius center is here, is the radius of the front well, the SVC, the velocity, the D is the distance here, and the omega you can calculate the phi c is the steering velocity. So we go to the vehicle motion control. This is a flow chart of the vehicle motion control. The first is start. Next is initialization. Receive velocity comments, velocity omega or motion control algorithm comments. Read the steering angle position. Calculate the steering axis velocity phi c. Send the steering velocity comment to the servo motor. Send the linear and angular velocity to the rear wheel controller. If it's not end, it will repeat to the step 3. And if yes, it's go to the end. We go to the human flowing algorithm. We have question, is the obstacle between the robot and the target? If the answer is no, the robot will decide it based on the direction. You can see the equation here, omega d. And if the answer is yes, it will avoid the obstacle first and continue to follow the target version, omega d here. The difference of two equations is the alpha and the phi de. You can see the alpha here, the d1, phi d1 and phi d2 here. It means if it has the obstacle, it will be following the blue light here or here, and it will choose the blue light here because it's close to the target person. We could go to the result. The navigation using joystick commands and running speed human flowing. The figure 1 is the motion trajectory of the robot, and you can see here the actor or guide the robot forward in a linear motion for about 3 meters and turn right, continue forward for 4 meters, turn right twice before finally turn left and move forward about 1.5 meters. At result, the steering axis motion spun smoothly and to the commands, and the steering angle was consistent with the robot motion. The meter 2 is the motion trajectory of the robot and the target person. You can see the blue light is the robot and the green light is the target. When the target go ahead, the robot go ahead. when the target turn left, the robot is turn left too. Next to human flowing with static obstacle, you can see the red one here is either obstacle, static obstacle. You can see the blue line, it's either robot. When the robot see the obstacle, it will keep the distance, and after that it's following the target. You can see image samples captured during the experience. The human following with moving obstacle. The target person walked forward about 18 meters, while an obstacle person walked beside him in a speed lower than the target person's speed. You can see whenever the obstacle gets close to the robot move away and keep the safety distance from the obstacle, and also to maintain the desired position behind the target person. So we go to the conclusion. After resolvable, we had 4 problems. They are steering wheel design for a 3-wheeled mobile robot, kinematic modeling, vehicle motion control, and collision-free human following navigation algorithm. We had a summary. The robot able to follow a target moving with speed up 3.6 meters per second, and we confirming the feasibility of the collision-free human following navigation algorithm. Thank you for listening to my presentation. See you again.